every project that we do, I use a METSIM model. I run an engineering company here in Golden, Colorado, called Global Resource Engineering Limited. We do consulting to the mining industry. My specialty happens to be in the process side, and we do studies, consulting, modeling, a variety of consulting around the mining industry. I first started using METSIM because I was before that I was using Excel, and I was doing a lot of heap leach modeling. And you come to find out when people are writing reports about heap leaches or people are running leaches, their expectation about sort of gold or copper delivered uh, in the early years is often wrong. You know, they assume immediately that you get to sort of steady state recoveries right away. And doing this inside Excel with circular loops and all those kind of things is gets very complicated, especially when you have multiple lifts in a big heap. And so METSIM provided an excellent way, one, to organize the heap leach in a structured manner, and two, to show clients that you don't get 70% recovery the day you put ore on the pad. In the beginning, when we first started using METSIM, we were really using it for fundamentally, straightforward problems. We were solving mass balances. But as we've gotten into more and more complicated projects, for example, cobalt recovery with copper precipitation and ion exchange and mixed hydrolysate precipitate, doing a mass balance inside Excel is just too complicated. And if you do manage to do it, if you ever have to make a change, then you have to make changes, globally throughout the spreadsheet. Whereas METSIM, I can do a scenario simply by moving the stream from one unit operation to another, is much easier with METSIM. And then the other thing is scenario analysis. So if you look at the size of your spreadsheet, I have a model with, multiple, say, several hundred instruments that, things that I'm tracking inside METSIM. And that would translate into several hundred columns inside Excel that would all have a formula in them, and it would be very complicated and very difficult to audit. It had a lot more flexibility to do all the things you want. I guess, from the standpoint of you need to know the chemical reactions, but METSIM allows you to do an infinite number of sort of combinations, permutations. And so we ended up going with METSIM. I had used Aspen previously when I was in the biofuel space, but Aspen is not really very good with solids, and it's very expensive as well in comparison. So my use of METSIM has evolved. Early stages, it was really just helping me along with mass balances. Fairly simplistic, but more difficult than sort of you want to do inside Excel. But now, we're really using METSIM, I mean, almost as a research and development tool, as well as, production validation. So the two areas that I use it, well, three areas. One, I use it for design. So for studies, I'll take test work and put it into METSIM, be it a concentrator or a heap leach. But also we're using METSIM a lot for production validation. So we've had a recent project where we have production from a copper heap, and we're matching the model to that production to do forecasting. And then most recently, I've done R&D. So we have an ion exchange pilot plant that we're working on. And METSIM has actually allowed us to discover some of the constraints that we were seeing in the field actually through the model.